Okay, so what I'd like to take a look at now is let's go take a look at our definitions for triangles. I kind of used them a little bit as we did that, but there's another sheet of the problems we just did where we're finding for x. But I'd like us to go back to those problems, and for the ones that had triangles, so letter D, E, and F, let's go use our labels for them. All right, so first, let's talk about which ones are acute, obtuse, and right. So acute, right, everybody's a 90-degree angle, or excuse me, less than 90 degrees. Obtuse, we have an angle that is larger than 90 degrees. And right, we have a right triangle. So going through those, right, this one's the pretty obvious one. This is a right triangle. Reason being is because we have a 90-degree angle there. So that one was easy. This guy right here, especially after we just finished doing that, I think we found that all the angles were going to be acute. So everything is less than 90 degrees here. So this one would be acute. All right, so there's our acute one. And then this guy, that little unknown angle, when we take a look at that, this little unknown angle is definitely past 90 degrees. So this one would be an example of an obtuse triangle. So again, right triangles have a 90-degree angle in it. Acute, all three angles are less than 90 degrees. Obtuse, there's one angle that's larger than 90 degrees but less than 180. All right, so there's the first round. The next round of being able to categorize my triangles is by calling them equilateral, isosceles, or scalene. So equilateral are when I have the all the sides are the same. All right, and so when we take a look at this, these are definitely different sides. Right here, right, they're different sides. This side would have to be longer than this one, and this looks a little bit longer than that. So, tell you the truth, we could probably answer these. This looks like it's scalene, and this also looks like it's scalene, due to the fact that, right, none of the sides are equal. So we have actually two scalene ones. This one right here, right, almost looks like it's equilateral, but in order to be equilateral, all the angles would have to be the same. And so these two angles are the same, this one's not, so that probably rules out equilateral. What's left, though, is isosceles. And that is clear because if these angles are the same, that means that these two sides have to be the same, which makes me isosceles. Right? This angle right here is different than that one, so that rules out the equilateral one. Okay, so there's just kind of a visualization of our categorizations of triangles. The first round is right, acute, or obtuse, and the second round is are we equilateral, isosceles, or scalene. All right, staying with triangles, let me see if I can do this with my my video here. Right, the next set of things we want to do is take a look at similar triangle situations. Right, it looks like I was successful there. So remember, what makes us similar is the corresponding angles are the same, and that the sides are basically proportional to each other. So when I look at this situation, right, that angle corresponds with that angle. Right, this angle corresponds with that one, right, and then it looks like this obtuse angle corresponds with that. So we have angle correspondence. So that's the first set of good news. In order to be similar, though, the sides have to be proportional. So right here, we could take this side, right, is corresponding to that side, and this side is corresponding to that side. So the ratio I can build, I can say 15 is to 12, right, for this big for this big obtuse triangle. And that would be that this corresponding x is corresponding to that 8 over there. Now, of course, what makes this interesting, we could set this up a lot of different ways. We can flip them on its head and whatnot. But there's probably the best way. Set a proportion up for this guy. It should be equivalent to its corresponding proportion on that guy. That way we kind of keep fractions within one triangle equivalent to fractions in the other one. Of course, like I said, we could have said the same thing by flipping it around. Either way, it's going to be the same value. How do we find x here? Well, again, since I have a proportion, probably the easiest way is to actually perform a cross multiplication. So 12 times x is equal to 15 times 8. So to solve for x, I'll divide both sides by 12. And what we get here, right, is we have to reduce this. I think 3 goes into 12 4 times and goes there 5 times. And then 4 goes into itself once and into there twice. So it looks like we have x equals to 10 in there. So 15 is to 12, like 10 is to 8, right, is what we're basically saying there. All right, the next one is a tough situation because rather than having two nice separated triangles, we actually have triangles embedded in other triangles. So the challenge here is to see that we do have, and how about I do this? I'm going to kind of redraw that smaller one there so we can kind of see the similar angles, the corresponding angles. So obviously that right angle corresponds with that right angle, right? And then this angle here would correspond with that angle there. And then they both share, right, that very acute angle there. So again, if we think in terms of the big triangle to this little one, right, the right angles correspond to each other, this upper angle corresponds to each other, and then they both share, obviously, that same thing there. So the first thing that all the angles are corresponding, right, are equal. And so now what we can do is relate a side. So if we take a look at the big guy, right, here's what we have. We know that this is 60 and that this whole entire side is actually 140. Let me change pens. If we look at the little guy, right, what we have is this is h and this is 100. So hopefully you can kind of see that. Again, it's kind of hard to see, but there are actually two triangles in there. There's the big one, which is the side of 60, and then if we add up everything, 40 plus 100 is 140, and then the little guy I marked in red, we have this side as h and this side is 100. And so now we actually have everything we need. We can basically say that 60 to 140 is the same thing as h is to 100. Of course, you could also say it the other way around. 140 over 60 would be the same thing as 100 over h. You decide how you want to orientate your proportion. All right, so this side and h are corresponding, and then this long side is corresponding to that side there. And that's basically what that's saying. 60 is to 140 as h is to 100. So now that we have our equation, we can simply cross multiply. 60 times 100 is the same thing as 140 times h. If we divide both sides by 140, right, we basically have h is 60 times 100 times 140. And just like I did here, you might want to fight the urge to multiply everything out because I can see some common factors. Clearly 10 goes into 140 14 times, and there's 6 times. And then it looks like 2 goes into 14 7 times, and 2 goes into 150 times. And I think that's about it. So our h is 6 times 500, or 50, which I believe is 300, and then divided by 7. We actually have a fractional answer here, which I wanted to make sure you guys saw because I just noticed that in most of my examples everything came out nice and neat, and we know in mathematics that doesn't always happen. You could leave your answer this way if you want, just in terms of terminology. What's nice about this fraction, it's already in lowest term. There's no common factors. If you want to change it to a mixed number, you can. I believe 7 goes into 30 4 times the remainder of 2. 20 divided by 7 is 2 with the remainder of 6. So I believe that would be the mixed number. So you guys choose. Again, I don't really care. I just want to make sure whatever fraction you have is in lowest terms. And it's your choice. Do you want to keep it as an improper fraction, or do you want to change it to a mixed number? That's for you to decide. Of course, I think my math lab also varies. They usually probably want a mixed number, so just be careful and make sure you follow directions. Okay, so that wraps up all the lesson and all my videos for section 1.2. We talked about vertical angles and transversals and all their relationships. We talked about triangles and all their relationships and similar triangles and all that stuff. If you have any questions on the videos, please ask. Send me an email or pop a question in the Canvas discussion board and start getting Canvas points. Of course, for now, as you've taken your notes, go do your My Math Lab homework. Make sure you practice the skills so that you're ready to take the quiz and keep moving forward. Thank you for your time and your effort, guys. Email me if you have questions.